In this video lesson, we'll talk about the do-while loop and the for loop. The do-while loop is new to us from our past experiences, but the do-while loop is a post-test loop, and it always executes at least once. All right, so that's what you need to understand about the do-while loop versus the while loop. The while loop may never execute because it's a pre-test loop. But the do-while loop is a post-test loop and always executes at least once. So the basic structure, we have the keyword do. We have a statement, takes one by default. If we have a block of statements, then again, we're using curly braces. We have the keyword while, where we have our test expression, but take note to the semicolon at the end of the expression. That's different than what we had in our last lesson. So what does it look like? So x is equal to 1. So it's going to do this. It's going to see out 1, and then it's going to test. So while 1 is less than 0, well, 1 is not less than 0, so that's a false statement. So it will not execute the body of the loop again. Only while the statement is still true will it execute. But it executed the body of the loop first, and then it tested to see if it should execute again. So in our example here, we're going to enter 3 scores. They're going to find the average, so we enter 3 scores. They're going to find the average, and they're going to print out the average. So they're doing all of this, and then they ask, do you want to go again, asking for a char value of a y or an n. And it says, while again is equal to uppercase y, or again is equal to lowercase y, then do this again. So while this is true, then we'll do the body again. But if it's not true, if they're both false, then it will terminate the body of the loop and move on to the next execution. So here the users entered 3 numbers, found the average of the 3 numbers, asked if they wanted to go again, so they entered lowercase y. So while it was an uppercase or lowercase y, it did the body of the loop again, asking for 3 scores, printing out the average, and then the final iteration, they put in something other than the 2 y options, and the body of the loop failed and moved on to the next execution, which was to terminate the program. So the do-while loop, loops always execute at least once because it's a post-test loop. It continues as long as the test expression is true and stops repetition once it is false. It's useful in a menu-driven program to bring the user back to the menu after they've made their choice. So if they've had a couple choices on their menu here, okay, and let's say the third option was to quit, then the idea is that they showed the menu, but if they chose to quit right off the bat, then the program terminates. Otherwise, it will loop back up as long as they choose 1 or 2, then the body of the loop will continue to execute. So the do-while loop, a post-test loop. So let's take a look at the for loop. We used the for loop last year in our experience, and it's the same in the way it executes, but very different in the way it is coded. So it is used when we know the number of iterations. The while loop and do-while loop are good when I don't know the number of iterations that I want to execute. But the while loop is best chosen when I know the number of iterations. It has a control looping structure in the idea that it has an initialization, a test, and an update. And so as long as it's within the boundaries of the test, it's going to continue to execute. There is no semicolon at the end of the parentheses, but everything is in the parentheses. It has 3 elements: the initialization, the test of the loop, and the ability to update it so that we're not caught in an infinite loop. If we recall from previous experience, we had for x equals 1 to 5. So the idea, as long as x went from 1 to 5, the body of the loop would execute, and we would ask for the next x. And so the initialization was x is equal to 1, and then it performed to the body of the loop. So we're going to have the initialization. It's going to execute the body of the loop, and then it's going to test, or it's going to update. So that was that next x. So here's my incrementer, my updater. and it's going to test to see, is it still valid? 2 was, within the range of 1 to 5. And so it's going to execute the body of the loop. It's going to update, okay, and then test to see whether or not it should continue. So it initializes, does the statement, updates, tests. Does the statement, updates, test. Does the statement, updates, test. The initialization only happens once. So it performs the initialization, evaluates the test that it's still in the range. So it's a pretest loop. So we still need to make sure that our initialization is appropriate within the test. It evaluates the test. If it's true, it does the body of the loop. If it's false, it's going to terminate the loop. It's going to execute the update and then retest as long as it's valid. So here we have the example, they initialize count to be an int and then count is equal to 1. So as long as 1 is less than or equal to 5, it's going to print hello. It is going to increment count to 2. Okay, so count becomes 2. 2 is less than 5, so it tests. And since 2 is less than 5, it prints hello. And it increments count to 3. 3 is less than 5, so it prints hello. And increments count to 4. 4 is less than 5, so it prints hello. Increments count to 5. 5 is less than or equal to 5, so it prints hello. And increments count to 6. 6 is not less than or equal to 5, so it terminates the loop, and count remains at 6, like we had in the while loop in the previous video. But the idea that it initializes first, tests it, and then executes the body of the loop, does the update, tests, does the body of the loop, updates, tests. As long as the test is true, it increments the body of the loop. Otherwise, it fails. So just kind of to recap, it performs the initialization expression, evaluates the test expression if it's true, and then it goes to step 3 where it executes the body of the loop. And then it goes back to step 2 where it is going to, or step 4 is going to perform the update and then go back to step 2. So after the initialization, it will constantly run this path, making sure as long as it's true, it's going to update and it's going to perform the body of the loop. Now, what I want you to understand about this update, this incrementer, here they're incrementing by 1. If I want to increment by something more than 1, which we use the word step in our previous experience, then I can do count is equal to count plus 2. I can do count is equal to count times 2. I can perform other types of operations in there. We can decrement if it's appropriate to decrement. So I can work backwards if I wanted to. And so anything that is a valid math expression for me to use then to test can be used in that update expression. So you're not limited to just incrementing by 1 or decrementing by 1. You can actually change that using a math expression, any type of math expression. This can be a variable as well as the part of the test expression can also be a variable. So in this example here, we have the min number of 1, max number of 10. So they ask for number squared. And so this is going to start at 1. As long as 1 is less than or equal to 10, it's going to print 1 to the screen, tab over, print it square, increment num to 2. 2 is less than or equal to 10, so it's going to print 2, and then 4, increment to 3. 3 is less than or equal to 10, and so on, and print out the number and the square value from 1 to 10. When to use the for loop in any situation that clearly requires an initialization, a false condition to stop the loop, and an update to occur at the end of each iteration. And it is a post-test loop. It is a post-test loop it is a pretest loop. Okay, it may never execute like the while loop. It may never execute. And when do I want to use it? Whenever I know the number of iterations is the best time to use it. If I'm not sure of the number of iterations, the for loop is not my best choice. Okay, so the for loop tests its test expression before each iteration, so it is a pretest loop. Okay, and so here's an example. Count is equal to 11. 11 is not less than or equal to 10, and therefore the body of this loop will never execute because the initial test is not true.